So what happens as intermolecular forces get stronger as you go, say, from a London dispersion force to something a lot stronger like, say, a hydrogen bond forces? How is it going to change the physical properties of what you're dealing with? Well, not surprisingly, those properties will generally increase. And what properties are we talking about? Well, melting point will increase. That's boiling point will increase. Maybe you can guess what each one of these images stands for. That's showing an attractive force within and at the surface especially. So that's surface tension. This is viscosity, and I think that will increase, but I don't know how often. I think that's a little, might depend on tangling and the shape of the molecules, not just their intermolecular forces. Things will tend to get more soluble. Certainly the greasy substances are insoluble in water. Those that can hydrogen bond are oftentimes soluble in water, depending on how much grease is attracted to them. For example, butanol is insoluble in water, but propanol is soluble. And the density might increase as well as those intermolecular forces get stronger. The bonds get closer together, or I should say the intermolecular forces make it closer together, and you may see an increase in density. Be careful because there's plenty of exceptions for all of these. Let's answer a couple questions. Let's try to explain this boiling point trend. I'm not exactly sure why water's not exactly at 100 here, but still I see that the boiling point of water is the highest, and we get a big drop when we go to H2S, working its way back slowly up as we go to H2TE, dihydrogen telluride. Now, it might not be clear what's going on here, but I had to memorize the periodic table many years ago, and I did the columns, and I made up these little words. So I said OCDPO, oxygen to sulfur to selenium to tellurium. I'm pretty sure polonium is next, but it's radioactive. And they are just working out the hydrogen, dihydrogen, oxygen groups. Why so high for water? Well, that's a particularly strong form of a dipole-dipole interaction, so it'll have a much higher boiling point. Then it'll be a big drop because this one cannot do that, but there's still dipole-dipole interactions, and these things will increase as you go from sulfur to selenium to tellurium because the atoms are getting larger, and therefore the possibility of distribution of those electrons a little unevenly becomes higher. The magic word there is polarizability. So for here, hydrogen bonds possible, not there, but as we work our way up this trend, polarizability increases. So that's our answer to explain the boiling points there. As we work our way from methane to the equivalent molecule for silicon, germanium, and tin, once again, when I had to memorize the carbon group, I said, let's call it Cussy-Gessen-Pub. Cussy-Gessen, and lead would be next. So we're working our way down the carbon group, where the polarizability will increase. None of them can form a hydrogen bond, so it will simply increase due to the polarizability. Therefore, the boiling point will increase with the maths, and watch out for hydrogen bonding. It's possible there, so you get a big leap. Here's another one, and the answers are going to be very similar. Now here we've got to really take a second to look what's going on because our trends overlap a little bit. HF, HCl, HBr, HI, fluorine to chlorine to bromine to iodine. We're working our way down the halogen group. The only one that can hydrogen bond is HF, so we get a big leap there. And then polarizability increases as you go from chlorine to bromine to iodine. Same thing for the nitrogen group. NAPASB was what I made up. Nitrogen to phosphorus to arsenic to antimony, and I think bismuth would be next there, just on the borderline between radioactive and not. And that's what's going on. Polarizability increases throughout, but nitrogen to hydrogen is a special case. That's a hydrogen bond force there, and here polarizability increases. Very similar answer. This is a look at intermolecular forces and how they can change physical properties.